Yeah, hi guys. Very good evening to all of you. So we are today we are with some new topics, and basically what we will do today. What we will do today. So we are done with programming constructs as of now. Like the programming constructs that are done, that is the basics of programming. To understand the basics of programming, whatever it is, like loops, uh, if else conditions, arrays, strings, memory management, classes, objects, all these we have done in our previous playlist. So if you have not done that, if you are new to this channel, please go and watch that, because if you will cover those topics, then it will be very easy to catch up the next coming up things. Okay, okay. So let's start with today's session. So, what are we going to start today? What are we going to start today? So, we are going to start introduction to problem solving. So, what is it? What is it? Like in the previous classes, we have done many lead code problems. But we were not at that time we were not considering the very efficient condition, right? We were not considering the very efficient condition. So, so, so what we are going to do now? What we are going to do now? We are going to discuss those problems which we have discussed earlier, and in that, we will try to come up with some efficient solution. So, yeah, hi guys, hi everyone, very good evening. So, now we will train ourselves to solve these DSA problems. So this class will be mostly theoretical class, but you will get to learn many things. You will get to learn many things. So as of now, what we have done, we have covered programming constructs. We have we have covered programming constructs, right? I hope the spelling is correct. This is done. This is done. So if you want to cover this, you have to go and check our previous playlist. And what is the second one? What is the second one? Which we are going to cover now. The second one is problem solving construct. Problem solving construct, right? And in this one, we will try to we will try to cover the efficient way of solving the problems. As of now, we were just our aim was to just solve the problems, but now we will try to do it in the efficient manner. Okay, okay. So let's start with our first problem. Let's start with our first problem. So let's think, this we have already covered, guys. This we have already covered, but still, uh, suppose we have a number is given n, and we have to count the factor out of that. So the problem is, given a number n, count the number of factors in that. Given a number n, and you have to count factors in that. So this is the problem. So every one of you done this already. Every one of you has done this already. Just give me a second. I want to fix the camera a little bit. Okay, okay. Actually, the camera was not at the correct angle. So what we have done, we have just tried to keep it little on the top. So the question is given a number n, and what we have to do, we have to count the number of factors out of that. So this is the number, this is the number. So we already discussed like what are factors and all. So what is a factor? What is a factor? So if we want to discuss that what is a factor, so like for 8, the factors are 1, 2, 4, 8, right? So these are the numbers which can divide 8. These are the factors. And this problem we have already discussed in the previous classes. So if you have not done that, please go and check it out. 1, 2, 3, and after that we have 4, 6, 12. These are the factors of 12. Okay, okay, got it, got it. So, so, like, what observation we are doing here? What observation we are doing here? So, first thing what we can see is the smallest factor, the smallest factor is 1, is 1, right? And the largest factor, the largest factor, that is that is that is the number itself, that is the number itself, right? Right. And the third thing is factor, a number is a factor if n modulo I is equal to 0. Then we tell that I is the factor, right? When we tell a number is a factor, when we tell a number is a factor, n modulo I is equal to 0, then we tell I is a factor of n. Right? Right? Everyone okay with this? Understood? So if that is the case, if that is the case, so let's try to do this problem. Let's try to do this problem. So if that is the case, so how we can solve this? How we can solve this? So what we have to do is, like, we have done this already, right? Suppose we will create a for loop, and that in that for loop, what we will do? We will iterate from 1 to n. We will iterate from 1 to n. And when we will iterate from 1 to n, what we will do? We will check that n modulo I is equal to 0. If that is true, if that is true, then that particular I is factor of n, right? Right? So, uh, so what we can do? What we can do? So this can be the brute force approach, right, guys? This can be the brute force approach. So what is the brute force approach? So we can have int count factors, and this will get parameter as n, right? Right? And in that what we'll do? We will initialize a count. We will initialize a count, int count, because we have to count the number of factors of that number, and we will initialize it to 0, right? And now we will write a for loop. Now we will write a for loop, and which will start from int I is equal to 0, int I is equal to 0, and then, okay, no, it will be from 1, right? Because the factors start from 1. So int I is equal to 1, I less than equal to n. So from where we have observed this? We have observed this from this. The smallest factor is 1 and largest factor is this one. We have observed this from here, right? Right? Okay. So we will go like this. And after that, we will write something like I plus plus. And in that, we will have if n modulo I is equal to 0. So then what we will do? That means that particular I is the factor. So if that particular I is the factor, then increment count, right? Right? So this, what this tells? I is factor. When we come inside this means that particular I is factor of this. And after this, suppose if we will write this, just a second. Yeah. Huh. So after this, yeah, this is this one and this is this one. And suppose it is done, then what we will do? We will return, we will return that count, right? We will return that count, right? Okay, done. So, as you can see, that this if is running from, okay, my God, this is running from here to here. This if is running from here to here. And this for loop is run. I have to take that line again. And this for loop is running from here to here. So in this way, we will get the count. In this way, we'll get the count. Understood. Understood. But can you guys understand one thing? That here we have to start from 1 and go till n. Like if we have 100 as n, like if the value of n is 100, then this loop will run 100 times. Understand that particular for loop will run 100 times. And if by any chance the value of n will be 1000, then that particular loop has to run 1000 times. So today we will understand that how costly that could be. How costly that could be. We will understand that. And why we should learn DSA. Because if you will not learn DSA, then how much harm you can give to your company. Okay. So suppose what we have is, suppose what we have decided, suppose we have decided 3 points, and these 3 points are, suppose here the number of iterations will be in the above code, the number of iterations will be n, right? It will be n, right? Okay. So the more the number of iterations, the more the number of iterations, the more the cost. Because what we want, what we want, writing a code, we want that the code should be optimized. It should take less time. And if we are taking more time, then it is costly, right? It is costly, right? Okay. So here our motto is to reduce that reduce that number of iterations. Here our motto is to reduce that number of iterations. How we can achieve this? How we can achieve this? Because you can understand that if we are having n is equal to 1000 and we are going to do 1000 iterations, then it is definitely not a good way to write a code, right? Okay, okay. Okay, and let's do one assumption. Let's do one assumption. Uh, let's do one assumption, guys. What we are assuming, what we are assumption, what we are assuming is, suppose, uh, yeah, let's take something like this because the loop is not doing much. So 10 to the power 8 iterations. When we do this much iterations, then it takes 1 second. This is our assumption. Okay, this takes 1 second. Okay, okay. So this is what we have assumed. Like if we are going in that loop for 10 to the power 8 times, then it takes 1 second. Okay, understood, understood. So this is what we have assumed as of now. Okay. So so can we create a table here Let's create a table. Mhm. This is why I'm doing this, guys. It is taking too much time. It was not required. I'm sorry. How to increase the length? Okay, that's okay. Uh, let's remove it. Why to waste time? I was thinking to make it more attractive. That's okay. Let's not need that. We can do it by ourselves. So we have something like this, right? And we have something like again. Hmm. So according to our assumption, what we have n, we have iteration, and we have something called time. Okay, we have something called time. So what we have decided as of now that if we have 10 to the power 8 iteration, sorry, we have n is equal to 10 to the power 8, then the number of iteration is 10 to the power 8, then the time it will take is 1 second. And if we have n as 10 to the power 9, like what we are trying to do, we are trying to get all the factors for 10 to the power 9, then the number of iterations will be 10 to the power 9, because it will run for 10 to the power n times, sorry, 10 to the power 9 times. So as we know, unitary method, that for 10 to the power 8 iteration, it takes 1 second. For one iteration, it will take 1 by 10 to the power 8 second, right? And for 10 to the power 9 iterations, it will take 1 by 10 to the power 8 into 10 to the power 9. That means 10 seconds. I assume you guys understand this. This is very simple math, so you should understand this. So if the number will be 10 to the power 9, then it will take 10 seconds. That is okay. That is completely fine. Like 10 seconds, it's okay. So let's go ahead. Let's go ahead. Think of one thing, guys. Think of one thing. Like suppose the number which we are using, suppose the number which we are using is something like 10 to the power 20. Okay, 20. Now you will see the magic of powers. Suppose the number which we are using is 10 to the power 20. Like you want all the factors of 10 to the power 20. So the iterations will be definitely 10 to the power 20, right? Right? And similarly, the time it will take is 10 to the power 8 into 10 to the power 20. And this will be something 10 to the power 12 seconds. So can you guys assume what this is? This 10 to the power 12 seconds, what this time is? Can you think of that? Can you guys think of that? Can you have any idea? Can you? Let's see. Let's see. 10 to the power 12 seconds, right? 10 to the power 12 seconds. Where is my cursor? I second to year. So what is that? It was 10 to the power 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, see. If it is 10 to the power 12. What is the year we are getting? It is 31,709 years. 31,709 years. So it is something like 31,709 years approximately. And like when we handle a very large chunk of data, so getting any value of something around 10 to the power 20 is very common. Like I know you guys can't imagine that 10 to the power 20 as of now, but when you go and get deployed into some project, this number is very common. So if you are going to iterate a loop for 10 to the power 20 times, then it will take 31,000 years. That means you have to take birth 31,000 times to see the output. And there is one more thing. If there is any power cut, then it should again start. So why this example? Why this example? Because to make you understand what importance do we play in the companies. Now what we can do, we can optimize this particular code. We can optimize it. How we can do that? How we can do that? Let's see. Let's see. So let's try to optimize the code. Let's try to optimize the code. Improvisation. What we can do, guys? What we can do? Okay. So what we can do is, suppose we have we have three numbers, and let's that be I, uh, J, and N. Okay, I, J, and N. Then please pay so much attention here. Please pay so much attention. If I into J is equal to N, this means that I and J both are factors of N. So I know you understand what can be the optimized core for it, but you will not understand that how we have achieved that and why we have achieved that. So I into j is equal to n, then I and j are both are factors. Understood? Understood. That's simple. That's very simple. So if that is the case, so can we do something like this? Can we have something like this? Like suppose we have I and we have n upon I. And, yeah, let's take that. Okay. And here suppose n value is 24. Okay. So in the previous code, what we have written, we will iterate from 1 to 24, right? 1 to 24. So if 1 is the factor, and as we know that if I and j are factor, sorry, I and j is equal to n, then both are factors, right? And one more thing, what we can conclude from here, that if I is a factor, then n by I will also be a factor, because if we will multiply this, then it comes as n, right? So let's see that. So these 2 points you have to keep in mind. If I and j, we multiply I and j, if we get n, then I and j both are factors. And if I is a factor, then n by I will also be a factor, because if we multiply both of this, then we get n. Okay. So if we have taken n is equal to 24, then we will get 24. 1 is a factor, 24 is also a factor. If 2 is a factor, 12 is also a factor. If 3 is a factor, then 8 is a factor. 4, 6, 6, 4. After that, 8, 3. After that, 12, 2. After that, 24, 1. So these are the, when we iterate when we iterate I from 1 to 24, so we get these, we get these, right? Right? Let's take another example. Let's take one more example for that. So if we have I, if we have n upon I, and suppose the value of n, why you are doing this, why you are doing this, I'm not able to understand that, but that's okay. Let's do this once. You will understand why I'm doing this. If you have something like this, if it is 1, 2, 1, 2, 5, 10, after that this will be 100, this will be 50, this will be 20, this will be 10, and after that we will have okay, 10 is done, so it will be 20, it will be 5, it will be 50, it will be 2, it will be 100, it will be 1. Understood? Understood. So can you guys see one thing? Can you guys see one thing? That after this point, after this point, we are getting the same factors. Just what has happened is this came here and this went there, right? Same is the case here as well. After after this particular point, after this particular point, this factor came here and this came here. This came here. So what you want to say? What you want to say? So what I want to say is, if like, let's take like this, let's consider this as part 1, and let's consider this as part 2. So what we can get out of this, let's write the observation. Let's write the observation. What is the observation, guys? What is the observation? So all factors are available in part 1. All factors are available in part 1. Is it, guys? Like, can anyone confirm? All factors are available in part 1. So this is what we can conclude out of this. Okay, okay. So if that is the case, if that is the case, so can we have one thing like, see, here in the first part, I is always smaller than n by I. I is always smaller than n by I. In the second part, I I becomes greater. So we can use that as a condition. So what we can write? What we can write? We can write I should be always smaller than equal to n by I, right? I should be always less than equal to n by I. So from this, what we are getting? We are getting I into I should always be less than equal to n. So what we got is, if we will iterate from 1 to, if we will iterate from 1 to this particular condition, if we will start from 1 and we will iterate to this particular condition, then also, okay, why this, yeah, then also we can achieve that. Then also we can achieve that, right? Let's see that how. Let's see that how. Wait, let's see that how. So two things we have observed. All factors were there in part 1, right? All factors were there in part 1. And the another thing was, and the another range of range of first part was first part was from 1 to from 1 to I into I should be less than equal to n. Or we can, what we can write this, if we have I into I less than equal to n, that means I square should be less than equal to n. That means we can write I should be less than equal to root n. We can write this, or we can write I should be less than equal to root n. Anything will work. Anything will work. Okay, so let's write the code first, then we will understand that. Then we will understand that. So what we can do? Similar thing. Int count factors. Count factors. This time also we are getting n as a parameter in that. What we will have? We will have int count. Previously we had the same thing, right? Okay, int count is equal to 0. And now we will have a for loop. And that for loop, we will start from int uh, I is equal to 0, I less than equal to root n. How we will write this? How we can write this? We can write this using, we'll tell you, just wait. Just let it be. Let it be. So we will write this, and in that, what we will do? What we will do? We can write if n modulo I is equal to 0, then count is equal to count plus 2. This is the logic. This is the logic, guys. This is the logic. And after coming out of this, and this, we will return that count. So why you have written like this? Why you have written like this? Because what was happening when we are iterating from here till here. So when we are iterating from here to here, we are getting two factors at a time. Two factors at a time. Two factors at a time, like this. Right? Right? Understood? So that's why we are incrementing the count by 2 again and again. Okay. This is the case. Okay, understood. So can you do a dry run of some code for that? Yeah, why not? Let's copy this and let's take it little on the downward side. Yeah. Let's move it little on the down side. So we have this already understood. Can we minimize it a little bit? Sorry. Huh. Seems correct, right? Seems correct. Okay. So for okay, something went. No, it's not correct, guys. Why? Okay, let's move it here. That's okay. We will use it only. We will use it only. That's okay. So let's do the dry run. Let's do the dry run. So we will have I, we will have n by I, and we will have count. We will have these three things, right? And suppose n is equal to 24. Suppose n is equal to 24. So what we will do? and we have to go till I should be less than equal to root of n, right? So it means hmm, I should be less than equal to n. That means I should be less than equal to root 24. So that will be something around uh, I should be less than equal to 4 point something, and I is integer, so I will be 4. So I will be 4, right? I will be 4. So if I is 4, so it will start from 1, 2, 3, 4, and it will do I plus plus again. So it will go till 5. I will show you how. So if I is 1, so n value is 24. N by I value is 24. If I is 1, n by I value is 24. And if that is the case, then we will increment count by 2. So count will be 2 now. Okay, I was 1 initially. Now we have incremented the count by 2. Again go in do I plus plus. Now I will be 2. Go inside, check 24 divided by 2. Yes, it's true. So what will happen? It is 2. So it will be 12. So again we are getting two factors. So again increment the count by 2. So now it will be 4. Correct, correct, correct. Now again I value is 3. So it will be 8. So again we are getting two factors. So again increment the count by 2. So it will be 6. Understood? Again increment I, and I is 4, then n by I will be 6. So again we are getting two factors. So again increment the count by 2. Do I plus plus is 5, and 5 is greater than 4, so it will not go inside, so it is done. So from here we will get the count as 8, right? And we know that already. We know that, like, for 24 we have 1 2 3 4 6 8 12 24. We have these 8 factors. We know this already. Right. Okay. Now we have understood the code. Now we have understood the code. Now let's take the n value as 100. Now you will see the magic. Now you will see the magic. Now n value is 100. And if n value is 100, we will have I, we will have n by I, and we will have count. Now you will see the magic. If n value is 100, so it will be 1, 2, 5. After that, it will be 10. And after that, nothing, right? It is because I should be less than equal to root n. So I should be less than equal to 10. So it will go till 10. So I is 1, it will be 100. I is 2, it will be 50. I is 5, it will be 20. I is 10, it will be 10. So now please pay attention. Here for I1, we are getting two factors. So count will be 2. Count plus 2. Again for I is equal to 2, we are getting two factors. So it will be 4. Again two factors, it will be 6. Again two factors. Array, no, these are not two factors. These are the same numbers. But whatever we have written in the code, it will return something like 10, but that is not correct. So what we have to do? What we have to do? So we have to put one more condition, guys. Like, what will the condition? See, when I and n by I are equal, when I is equal to n by I, then what we have to do? we don't have to increment the count by 2. We have to increment the count by count plus 1. Okay, understood. So if we will increment the count by count plus 1, so this will come as 1, it will increment by 1, so the count will be 7. And you can see that it is 1, 2, 3, 4, 5, 6, 7 factors. Understood, understood. So now we got this. So now we got this, that you are telling something like this. You are telling something like this. Just a second. Mm, let's copy this code because it will be little tough to do the editing here. So let's copy it from here. Okay, let's copy it. So now the code will be something like, now the code will be correct code. So now the code will be something like, let's move it little on the top. This is not required. Let's move it, right? And in if we will not have like this. So now what we will write? Now what we will write? Okay, so if it is between this, we will go inside. We will check if if I if I okay, no, sorry. What we have done. Here we will have n modulo I is equal to 0. That means that means that is a factor. That is a factor. Okay. So when we will enter into it, we will again write a if condition. In that we will check that is I is equal to n by I. If that is the case, if that is the case, then do count plus is equal to 1. This is the alternative way of writing that. And if that is not the case, if that is not the case, like for this if that is not the case, then we will write else. And in that, what we will write? In that, we will write count plus is equal to 2. Understood? Understood? So we have this. Everyone got this. And at the last, we will return, after the for loop, we will return that count. After the for loop, so here the for loop is ending, we'll return the count. We will return the count, guys. So done. So now what we have done? Now let's go back to that table. Now what we have done? So here, what we have done? The number of iterations, if we have 10 to the power 20, if we have 10 to the power 20, let's make a line here so that we can. If we have 10 to the power 20, so the number of iterations will be something like this. Something like this, right? So that means it will be something like 10 to the power 10, right? So it will be something like 1 by 10 to the power 8 into 10 to the power 10. That means it will be 10 to the power 2. That means 100 seconds. See, guys, the change. See the change. Previously, for the same code, the time what we were taking was 31,000 years. Now it is just 100 seconds. See the power of the developers. Our Our mind, what we are doing with our mind, we are optimizing the code to this extent. See the difference, guys. See the difference. Liked this? Have you guys liked this? Can you please put a yes in the chat? If yes, have you guys liked this? If yes, can you please put yes in the chat? Why in the chat? If you have liked this, can you please put why in the chat, guys? Okay, okay, okay. So that is we are done with the first problem. Let's go to the second one. Let's go to the second one. So the second problem is, it's similar to the previous one. A number is given, a number is given, and you have to tell that is prime or not. A number is given, given a number n, you have to tell that is prime or not. So can you guys tell me the definition of what are prime numbers? Can you guys tell me the definition of prime numbers? Numbers which have exactly two factors are called prime numbers. Are called prime numbers. Please remember this. Please remember this. So again, now what we can do? Now how we will achieve this? Now how we will achieve this? This is this is like the extended version of the previous problem. So in previous problem, we were counting the number of factors, and if we know the number of factors, so we can write a normal if condition. If the count is greater than 2, then that is not a prime number, and if that is not the case, then that is a prime number. Simple. Simple, right? So what will be the steps? So what will be the steps for this? Steps to solve it. Steps to solve it. So what we'll do? Calculate number of factors. Number of factors. So if we have calculated that and we have did that, right? We have did that. We have just did that in the previous problem. And if the number of factors is 2, if if count of factors is equal to 2, if that is yes, if that is yes, then prime. If that is no, then that is not a prime. Simple, right? Simple, simple. So we can do that very simply. We just have to write the previous code. So what we can do? We can write the previous code, this one. So let's take this code. Okay, let's go ahead and take this code. Copy this. After copying this, what we are doing, we are pasting it here. And after pasting it, you're trying to minimize this little bit. Huh. Think it's okay. It's okay. We can understand that. We can understand that. So if we can understand that, if we can understand that, so here what we have int count factors, and that is giving the count. That is giving the count, right? That is giving the count. And what we can have? We can have this is a function. So from this we are getting the count. So if we are getting the count, so what we can do, we can just write a function. Uh, what we can do, okay, that is okay. I'm sorry. That is actually prime or not, right? So it will be Boolean. It will be Boolean will be okay. So Boolean is prime. We are making a function Boolean, and that is called is prime, and that is also getting a number into it. And if that is getting a number, so what we are doing, we are we are calling that function count a number of factors. So what is the name of the function? Just let me see. Count factors. So what we are doing int count is equal to count factors, and in that we are passing that n. So this function will give the count, right? So if we are getting the count, what we will do? We will check if count is greater than 2. If count is greater than 2, so we will write SOP, or we don't have to write SOP. Okay, just a second. We have to return true or false, right? If count is greater than 2, so it will be false. It will be false. Else, else it will be true. Else it will be true. Understood, right? Understood. So if you have understood this, we can optimize this further. We can optimize this further. How? How? So what we can do, let's take the code again. If you have understood, we have not done anything. We just took the count out of that function. We just took the count out of the function, and what we have done, we have checked if the count is greater than 2, then it is not prime. If the count is not greater than 2, then that is prime. That's simple. So optimizing further, optimizing further. So if that is the case, so can we have something like, let's minimize it. Let's take it on the top. Let's minimize it further. Let's take it here. Seems okay. Yeah, seems okay. Now what we can do is, now what we can do is, let's name the function as is prime. Let's name the function here as is prime. So it is Boolean. It is Boolean, and the function name is prime. Okay, okay. Now we are checking. Now we are checking the count. Now we are checking the count. So see one thing. So this is the scope of the for loop. Okay, let me see. I have done something wrong, is it? This scope, this is ending here. This one is that if is ending here. Okay, and that for is ending here. Let's make it. This for is ending here. Understood? So what we can do is what we can do is we will take this, and bring it little down. So we want nothing, just that the number is prime or not. That what we have done now, we have increased the scope. Okay, we have got some place. Let's take it again. We have increased the scope from here to here. So it is still here now. This is the scope of for. So what we are doing, guys, please pay attention. Please see. Please see. So here, see, we are incrementing the count. Here we are incrementing the count. And each time after coming out of the if, we will check. We will check if count is greater than 2. If count is greater than 2, then return tell me, if count is greater than 2, then what you have to do? If count is greater than 2, that means we have already found that the number is tell me, the number is not prime, right? So it will return false. Simple. Just close it here. And till the for loop has ended, if we have not received anything, then after this, here the for loop is ending. See, after the for loop is ending, we can return true. Understood? So this is how we can optimize the code. Okay. Or what we can do? I can tell you one more method. So if count is greater than 2, so what we will do? We will break the for loop here itself. And when the for loop is broke, that means we are helping us to reduce the iterations. And we will check here. What we can do, we can check here. If count is greater than 2, then return false, else return true. So the same problem we have discussed in 3 different ways. So it's not about remembering these solutions. It's all about having that particular mindset that, okay, so what we are doing is, firstly we were going from 1 to n. To calculate the number of factors, we were going from 1 to n. So we found one pattern that we can get the count by going from 1 to root n only. And this will reduce the iteration, and that will result in reducing the time to execute that code. Okay, once that is done, and that optimization of getting the count of factors we have used here in getting that, is a number prime or not, right? And if a number is prime or not, and again, we don't have to run the for loop the whole time. We can break it in between. If we got that the count is greater than 2, then we already understood. We already got the solution. Okay. So much of. Okay. Yeah. So what we will, okay, we are done with 2 problems. So guys, so this class was not on DSA or something, discussing any data structure or algorithms. This was about how we should approach the problem. we should how we should create the dry runs, how we should mainly we should see, like, where we can optimize that. So when you suppose you know these two, okay, these are very simple codes. So calculating a factor or knowing a number is prime or not, you know this. So in your projects, suppose you got into some product based company, okay, suppose you got into Amazon or Google, okay. So there what you have to do, there is a very large code base, and in that you want to calculate that factor, or you want to use that particular function. So what you can do, you can use that optimized approach, and that will finally result in optimizing your whole code base. I know you will be thinking that, sir, how, Akash, how we will get this factorization thing in our code base? So that is not only there, guys. There are many things. After after doing 200 plus problems in the class of lead code, there will be many things which will remain in your mind, and that you can use when you actually do some production for your companies. Understood this. So last thing for the day, uh, we have decided two things. Like, we will have two different playlists, okay. So this playlist is, as you have already seen, DSA Concord, right? And there will be another playlist for lead code problems. This we will start soon. I know you guys will be getting your assignments in your Excel sheets. You have to try it by yourself. If you are not able to do it, ping in the Telegram group. We will respond. We will definitely respond. In this lead code playlist, in this lead code playlist, we will solve around 250 plus problems. And again, I'm telling 100 easy, 100 medium, 100 hard. Sorry, 50 hard. Okay. And here we will mainly discuss the data structures and algorithms. Okay. And we will do some implementations, but not the lead code problems. We will do the implementations on IDE, but not the lead code problems. Okay. 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 So, yeah, understood. One thing. So, what you are going to get in this DS Concord, let's talk about that. In this DS Concord playlist, or in any playlist, I should say, actually, in any playlist, you will get notes. You will get notes. First thing, you will get the GitHub links of those codes so that you can understand that. GitHub links. You will get the implementations of whatever we have discussed in the class, of whatever discussed in the class. Yeah. And after that, notes, okay, and anything else I'm missing? Okay, the main thing. You will get lots of assignments, guys, lots of assignments. And you will get support as well to solve these assignments. Support to solve these. Okay, okay. Anything else we have? No, nothing. Okay, we are mostly done. So notes I will attach in the description. Don't worry, I will attach in the description. GitHub links that will also be in description. Yeah, these will also be in descriptions. Assignments. This assignments you will get in the Telegram group. Telegram group. And where is the Telegram group link? It is also in description. So go to the description, join the Telegram group, and there you will get some Excel sheets, and try to solve all the questions, guys. Try to solve all the questions. It's a long way, I know. It's a very long journey, but I can assure you one thing. After ending the whole playlist, I can assure you a single thing, that you will fall in love with programming. Okay. Like job is a very, very small thing. Uh, I know, guys, like for you, it's very tough. Like how Akash you can say that like job is a small thing. But the way we will go ahead, we will do everything that is needed to get a good job with a handsome salary. Okay. Okay. We are mostly done for the day. So please, yeah, please, there is a request. There is a humble request. Please like if you've liked the video. And what is that called? Comment. Please do comments, because that motivates us. This motivates us. This motivates us a lot. So please do comments in the videos. Thanks for the update, Shyam. Thanks a lot. I will just now update it. Please do like, comments, and what is another thing? Subscribe as well, because only 60% people who see our video have subscribed the channel. So this we get the data out of that YouTube analytics. And please share with all your folks who want to learn DSA. Thank you. Thanks a lot. We are done for today. Thank you. We will meet again. Bye bye. Yeah. Oh, okay. One more thing, guys. One more thing. I have not told you the homework. So the homework for today is you have to do the implementations. You have to do the implementations of all whatever we have discussed in the brute force manner and the optimized manner as well. Whatever ways we have discussed, you have to do that, and you have to ping that in the YouTube comments. Okay. Okay. Thanks a lot, guys. Thanks a lot. Okay. I will update that Telegram group